so let's pick up where we left off last time, which was with our Tic-Tac-Toe program. And let's just kind of go through what we had accomplished before, just to remind ourselves where we were at. So we've got the cursor moving, and we have it limited so that it only can move one basically grid unit at a time, and it can't move off the grid. And there are exactly 9 of the tiles, and I think we've got all of those things set. Um, and we created all the tiles and then set their tile state to be 0, which we were using for unselected. And then we were going to say, if memory serves right, we'd have tile state of 1 meant that it had been picked by player 1. Tile state of 2 meant it had been picked by player 2. Um, and then, so what we still have to do is we were in the middle of getting the selection feature working, which was the overlap business here. Um, so we were still working on that. And then we also need to get in some sort of functions to determine whether or not somebody has actually won, or if we are in a stalemate sort of situation. So that's the where we were at. So any question, preguntas, fragen on where we were ready to go? Yeah, you didn't watch the video from last time, did you? I stream all of this on Twitch and then it goes to YouTube, right? If only the professor were like somewhat technologically inclined and had learned a thing or two during the pandemic. Uh-huh. Yeah. So twitch.tv/Prof McKinney. Be sure to mash that subscribe button, right? Or what is it they all the YouTubers say? And hit that bell so you don't miss our new content, fresh new content. Yeah. So, mm, yeah. Okay. Anyway, so what we had decided to go with for the selection feature is to look for when 3 things happen simultaneously. The cursor has to be overlapping with a given tile, and the B button has to be pressed, and in order for it to actually select and change the tile, then the tile state has to be 0. Okay, meaning that you can't pick an already chosen tile. So when you pick a tile, we need to do a couple of things. We need to change the art that goes with it so that it looks like it should. And then second, we need to change the tile state of that sprite to be either 1 or 2, depending on what the current player is. So if the current player is 1, then we need to change the tile state to 1 and change the art to an X. Uh, and then otherwise we'll change it to an O. Okay, makes sense? Yeah? Okay. So what we'll need to do then is put another conditional inside here, and this conditional will be of the if then else variety, because we really have 2 cases, right? If it's player 1's turn, do one thing, otherwise do the other set. And because this is nested inside the other conditional, it will only actually get executed or even checked it won't get checked until the outer conditional is satisfied. Okay, so does that make sense? The nesting part. Yeah. Okay. Okay. So what's the condition that we need to check here? Well, other sprites. We already know that the sprite is selectable, but what we need to know is whose turn is it? And we had created a variable to keep track of that. Here it is. As player turn. Okay, so player turn could either be 1 or 2 was the way we were going to do it. So the if case would be if player turn, this number, is equal to 1. Oh, hold on. I got the wrong equal. I needed this one. Okay, so actually this is a mistake that is really easy to make. You see how one is in quotes here? So there's two equality checkers. One is for strings of text and the other is for numeric things. And I grabbed the wrong one. I grabbed the string one. And so you want the one that doesn't have the quote if you're checking numerical values. Um, the one for the that has the quotes is if you want to check text. So like let's say you have the player type in their name and you I don't know, you want to have like an achievement if their name is something silly, then you could check, is the player name equal to this piece of text? Yeah. Okay. So if the player's turn is 1, then what do we wish to do? Change the art to an X, change the state of the particular tile to 1, and now player 1 has just made a move, so we need to change the player state to 2. Does that make sense? So 3 things. Okay. So, well, let's just take those in order, right? So we want to change the art of the sprite to something. Okay, so if we go to the sprites menu, right, when we create a sprite, we have this little thing where we can change the art. But then down here, I can set the image for that sprite to whatever. Okay, so I'm going to drag that out. And then other sprite is the tile. So I'm going to replace my sprite with this placeholder other sprite. And then in the gray box, I just pick in my assets the X piece of art. Okay. All right. So that's set the art. What else do we need to do? We need to set the players, or sorry, the state of that. Um, okay. So set this one. We need to set other sprites, data, tile state. Oops. To 1 because the player has chosen it, and then we need to set the player state to, or player turn, sorry, to 1, and that we would do under variables, set player state, player turn, excuse me, to 2. Right, because what were we using? What were the player state values? They could be 1 or 2. And so if it was the first player's turn, they move, and now it's the second player's turn, and then vice versa. Okay. All right. So does that make sense? Yuji? Uh, okay. And then what should we do if in the else situation? So this would be the case when the player's turn is not 1, but rather 2. We should do basically the same thing, except what do we have to modify here? So it's almost the exact code. Well, if it's player two's turn, then switch the art to an O and set the state to be a 2 rather than a 1, and then change the player state back to 1, right? So this way the player state will always sort of flip-flop between 1 and 2, and that makes sense because that's like how the game is played last time I checked. Maybe. It's been a while since I played Tic-Tac-Toe. You would so beat me. I don't know who gets to go first. Hmm. All right. So, does the logic, oops, and looks like I accidentally desocketed that. Okay. Okay, so this should be good to go. Let's test it out. So, as we said before, I can move my selection thingy and if I hit B, okay, there's an X, and then that one's an O, X, O, X, O, X, O. Okay. So the art is correctly switching. Looks good. Yeah. Okay. So what that seems like it works. And also, if I try and select an already chosen tile, then nothing happens, and that makes sense because I shouldn't be able to select something that's already been selected. That's not how tic-tac-toe works. Um, Actually, that'd be an interesting variation where you could either move or flip somebody else's to yours. Is that like, I've never thought about that until just now. Yeah.
I know, like, if I've seen like tic-tac-toe, but like you're running back like across a basketball court, like an obstacle court, and then you have to like go and like put something to like be like an extra or whatever, and you run that like relay race,
Uh-huh.
and then like if it's a tie or whatever, then when the next person goes up, that they like switch it, or like they didn't have enough, like they would have like maybe 8 of the things, and then they would like switch it.
Okay. Huh. Yeah. It'd be interesting to think sort of about the mathematics of, how you would model such a game, um, where you could flip it. Um, yeah, but yeah. Okay, so it looks like it works. And the selector, because we generated it last, is always on top of the other sprites. Um, and I think we realized last time that I made all of these things 16 by 16. I really should have made them 32 by 32 because we're wasting a whole lot of screen space, but whatever, right? For demo purposes, it's fine. Um, okay, so we've got the selection working. Now what? Yeah, we need to have something that's checking for winning and losing. Okay. And also, there's one other thing that I want to do, which is um, we started talking about, well, how are we going to check whether or not there's a stalemate, right? So, what really is a stalemate in tic-tac-toe? Nobody's won, and yeah, all 9 tiles have been chosen. Okay. So if we increase a counter, and we made the counter called tiles picked, if we set that to 0 when the game begins, then, and each time we pick a tile, we increase this counter by 1, then every time that we're checking whether or not somebody won or lost, we should also check whether or not that number is equal to 9. Because if that's the case, then um, all tiles have been picked and it's a stalemate. Okay. The other thing, actually, that it means is that do we need to ever check um, or that we only need to check whether or not somebody has won or lost as long as that count is less than 9? Because if it ever equals 9, we know that that's going to be, well, no, not necessarily. I suppose it is possible that somebody could win with the 9th pick if you like really, really, really tried hard to lose, or something. So, okay. All right. So, but we already went ahead and made the variable for it, tiles picked. And so every time we select a tile, then we can just increment that counter. And for that, we can just change it by 1. Now, I'm going to put that right there. Um, and let's think about the logic. Is it okay to put it there? So I put it outside the innermost if else block. Will it work here? So I claim that it will, but let's think about why it's okay. Yeah. Yeah, exactly. So what this will do is um, it doesn't matter whose turn it is for updating the tile picked. It just matters that a tile is pickable and has been picked, right? So this outer if condition is saying if the tile is pickable and it just got picked, then change the art accordingly and then update this guy. But since we're updating the tiles picked regardless of who picked the tile, we only have to put that piece of code once. We could put it, by the way, right here, right? Or right here. Or we could put two copies of it, one inside the if and the other inside the else, but which one's most efficient? Well, why have two things when one will do, right? So, yeah, so we'll put it there. Okay. So we've got that. And then at this moment, the tiles picked is going to increment every time we pick it, but we're not checking yet whether or not it ever equals 9. Okay. Similarly, we're not checking on whether or not somebody won the game. Okay. So we need to make a function or something that's going to do the win checking. And when would it be a good idea to do win checking? Well, what about immediately after somebody picks a tile? That makes sense, right? Okay. Why check any other time? Okay. So like before, let's just remind ourselves where we used a function. We used a function to generate basically all 9 of the sprites and get them all put where they belonged. We want to make another function that's going to be kind of like this, that's going to check whether or not somebody won or lost. Okay. And all right, so let's create that function, and you'll find that under advanced. And so let's create a new function. Okay. Okay. And let's check winner does not need to take in any particular values because it just depends on the game state. So we don't need to pass anything to the function. But what the function could do is it can return a number. Okay. And so under the function thing, you see there's this thing that says return something. Well, maybe it would make sense to have a return value. Okay. And so what was the game state? We had game state to we had initialized it to 0. Okay. And what were the values that we were kind of thinking for this? We were going to have 0 meaning that the game is currently being played, everything's fine. 1 meaning that player 1 had won, player 2 or 2 for player 2 had won, and then 3 for that there was a stalemate. Okay, so what we can do is we can have the function either return this game state or just change it to the appropriate value. Either way, yeah. And this is actually one thing that MakeCode. Well, let's see. Okay, so let's talk about what's called scope for a second. So let me go into my variables list, and you see there's a whole bunch of things there, right? Do you see tile state in that list? No. But tile state is a variable that we've used. So where is it? Okay. It's not in that list, but it is a variable. So why doesn't it not appear on this list? There's a very good reason for this. Yeah. Sort of. I mean, that's how MakeCode is organizing it, but it's on the right track in the sense that we made the tile state as a data variable within a sprite. So that piece of information is local only to that sprite. All of these variables are what are called global, meaning that they're all accessible throughout the entirety of the program. Okay, so the difference between local and global is MakeCode mostly hides this because this is this is a pretty high level concept for a kid to kind of understand. right? So the idea is that you can have global variables that are accessible everywhere within the program. And then you can also have variables that are sort of local that only apply within a small piece of the program. And what's advantageous about that is local variables can have the same name as local variables elsewhere. Where this is really handy is with numbers or variables like I, J, K, things like that, where you're counting through a list. You use those letters too often to want to have to come up with new ones every time you do go through a loop. Okay. Um, yeah. So that's the distinction here, right? And the reason it makes sense, of course, is because one tile could have one value and the other tile could have another value, but I don't want to have 9 tile states variables. I mean, I could, but that would just clutter up our variables list. Okay. Now in MakeCode, it doesn't really make a huge difference whether or not you do it global versus local. But in real programming, you want to avoid using global variables if at all possible, because there are consequences in terms of memory and computational efficiency and a whole bunch of other things. Um, so the only stuff that you would ever want to define globally would be things like um, stuff that, of course, the entire program needs, and also things maybe that don't change. So, for example, let's say you were writing a big program to do a bunch of math. It would be completely legitimate to define pi as a global variable because there is only one pi, right? And it's not like it's going to change throughout your program. Okay. Although, I mean, we are in Indiana, so who knows? Maybe pi will come along and change one day. Do you guys know about this story? This is so a little over 100 years ago. There was a bill before the state assembly in Indy, and amongst other things, it would change the official value of pi within the state of Indiana to 3. Hmm. Yeah. Now, I'm being slightly facetious here because what the bill actually was about was so in mathematics we have, and I suspect that there are other disciplines that have this too. In mathematics, we have this phenomenon of what we call cranks. Okay, so these are people that know some math, but they're also morons. And so they think that they've discovered like really amazing stuff, but it doesn't pass muster with the mathematical community. Or what's more often the case is that they claim to have proved things that like legitimate mathematicians know is impossible, right? So there are problems that we know are impossible to solve, and they claim to have found a solution to it, right? So they're basically crackpots. Um, and they annoy us and spam editors and stuff. And then you sometimes get like conspiracy theory elements to it where like, well, big math is just trying to keep their discoveries secret or something, and that it's a big conspiracy against their discoveries. Um, and then they file lawsuits and so yeah, it's really hilarious. Okay, so anyway, there was this guy that claimed to have discovered a bunch of miraculous things, and what he basically was trying to do was get the state assembly to recognize him as the discoverer of these amazing things that are wrong. Um, and in exchange, those things could be taught in Indiana public schools without any royalties for his discoveries. And one of the consequences of his so-called discovery is that pi is 3. So the purpose of the bill was not expressly to rechange pi to be 3, but that's how the story plays out. So you can look up the Indiana Pie Bill. It's a fantastically hilarious story. Um, and what I find most hilarious is that that's happened here in Indiana. Because I mean, this is something that you'd expect out of like Alabama or Arkansas, but no, it happened here in Indiana, right? Huh? Well,
Sounds like
but
this
why
might be
not
a
round down to 3.1?
so well, technically when we round up to 3.2,
Okay.
then with 3.14 equals less than 5, it
Yeah,
should
so you would
count.
round down to 3.1, not 3.2.
Oh no, 3.0. This guy sounds like a man of the people. It sounds so much easier. You try to make pi 3.2. Try to round up to 2.
Well, it wasn't from rounding. It's so this is the thing about his supposed discoveries is that they both imply that pi would be equal to 3 and that it would be equal to 3.2. Well, sorry, bro, it can't be both of those things. So, right. And that's how you know that he's a crank, right? Because it don't work that way. Anyway, so um, yeah, so sorry, that was a little bit of a tangent, but you would in general in like Python or real programming, like especially when you get into like enterprise level stuff that, if those of you or if any of you go into programming as sort of a career, you generally speaking want to avoid global variables. Now, for small programs, things that you're doing in kind of a classroom environment doesn't really matter, because nobody's going to die if we make a mistake in our code. But if you're programming as a career, it is in fact entirely possible that somebody could die because of a mistake you make in programming. Um, and so, what would be maybe good examples of where that could happen?
NASA.
Huh?
NASA.
Okay, NASA. So, and you may not kill the astronaut, but you could also crash the space probe into Mars. That happened in the 90s. Talk about that in a moment. Yeah.
Factory,
Huh?
like factory programming model.
Yeah. Factory stuff, automation, right? If the robot crushes somebody. Self-driving cars, right? And here's a really interesting question. If I'm in my Tesla, I don't have a Tesla, but right. I can have a Tesla, but I may have to double all of your tuition. How's that sound? Yeah.
You can do that in 3 years.
3 years? Okay. Sounds good.
Yeah.
Or if you all want to buy an A, the price is a Tesla and a plane ticket to a non
If you
extradition treaty
convince
country.
Turner to let me do that, I might consider it.
Yeah.
I find that counterintuitive. Like you just have to test them to get to the airport before you fly away.
Well, okay. Yeah, maybe the Tesla has to be waiting for me in the non extradition treaty country or something. Yeah.
I mean, I'm sure some alumni will be willing to open it up.
Alumnus. Alumnus.
Alumnus,
Yeah. Alumni is plural.
exactly. Alumni.
Or alum for
It's
short. Yeah.
8:30 in the morning.
It is? You mean you're not good with your Latin at 8:30 in the morning?
I can barely speak English when it's not 8:30 in the morning.
Yeah. Okay. So, yeah, self-driving car, like if a Tesla is in autopilot mode and crashes into somebody, who's liable for that? Am I, the owner of that Tesla, liable? Which would be the case if I were actually driving.
Elon Musk.
Or is Tesla as a company liable because they're the ones who programmed the autopilot?
Technically, the driver would sue Tesla for a faulty system.
Well, probably because they've got the deep pockets, right? So the victim, whoever got crashed into, would probably sue
Tesla for
this
damage.
Tesla and the person who owned the vehicle because they have an insurance company behind them, right? So, but it's an interesting legal question, how do you even conceive of that, right? Um, Hashtag liberal arts college. This is why you all came to liberal arts colleges, right? Because we have a very technical question that interfaces with a very non-technical thing, right? Yeah. Well, I don't have to give you guys the liberal arts college speech because you already drank the Kool-Aid and came here. So, yeah. Okay. But anyway, right? You guys agree that this is like a serious piece of concern. There's another story. The Theravac 25, I think it was. So this is a thing in I think it was Canada, or at least was manufactured in Canada. Um, for using like doing radiation therapy for people that have cancers or other things that can be treated with radiation therapy, and somebody misprogrammed it, and so it was giving people like 1,000 times the dose that they were supposed to get of radiation. Well, as you can imagine, that's not the best thing. And it was under this really, really, really limited set of circumstances that it would happen. And yeah, people got sick and died because of that. Boeing, I guess, was what's been the big news with Boeing over the last couple of years? Anybody? But the airplane maker. Yeah, the 737 Max. So they the plane they basically changed the dimensions of it compared to other models of the 737 in such a way that the weight was a little bit redistributed. And then, in order to make it feel to a pilot like they were flying a regular 737, they used a software system that would kind of adjust it, and so then a pilot wouldn't have to be completely retrained on the Max as if it were a new airplane, like from scratch. But there were problems with that software system, and it led to two planes basically crashing. And Boeing had to everybody grounded these planes, and they had to do a bunch of software stuff, and it's a big mess, and it's cost Boeing just gargantuan quantities of money. So yeah. Anyway, um, okay, so that's our liberal arts college side note for the day. So where were we on the program? We had just created the function over here as a placeholder for check winner, okay? And what do we need to do in order to check whether or not there's a winner? Well, first off, we only we know that a stalemate only occurs if there's 9 tiles that have been picked and there's no winner, okay? But we still need to check and see if there's a winner, okay? Um, how else do we know that somebody has won, though? Like, under what circumstances can you win in tic-tac-toe? 3 in a row, and how many ways are there for that to happen? 8 or 16, depending on how you want to count, right? But really 8, because it could be 3 rows, 3 columns, and 2 diagonals, right? So what we want to look for is there a situation in which a row has all 3 tiles with the same tile state, okay? But here's where we have to be careful, because what do those tile states have to be? They have to be the same, but they also have to all be non-zero, right? Because what are the tile states when the game starts? That's what they get to. Yeah, so we only want to actually check that in the situation that, like, if they're all 3 equal, that's not good enough, right? Because if they're all 3 equal, then technically there's a win at the very beginning of the game, right? Because there's 3 in a row that are all 0. Okay, so we want to say, are there 3 in a row that are either equal to 1 or equal to 2? Okay, does that make sense? Yeah? Okay, so this part's going to be a little bit messy, because, well, first off, how did we name our tiles? So if memory serves, we did 1, 2, 3, 4, 5, 6, 7, 8, 9, where 1, 2, 3 was the top row, 4, 5, 6 was the middle row, and 7, 8, 9 was the bottom row. Yes? Okay, so let's get the logic in for checking the top row, and then all the others are going to look very similar. It's just which tiles we're checking is going to change. Okay, but the idea is almost identical. Okay, is that the big picture make sense? Okay, so we need to look at 3 numbers. We need to look at the item data as number for tiles 1, 2, and 3, and the tile state is the variable within it that we need to look at. So we're going to need 3 of these things. Okay, and I'll just copy some placeholders in for now, okay? And then which items do we want to check? Well, we want to check tile 1, tile 2, and tile 3, namely the guys that are in the first row. Okay, now eventually we'll have to kind of do this same thing for 4, 5, 6, 7, 8, 9. The columns, which would be what? 1, 4, and 7, 2, 5, and 8, 3, 6, and 9, and then the two diagonals. Okay, but let's just get it to work with the top row because the rest of it'll basically be copy paste. Okay, so what has to be true about these things? They all have to be the same, and none of them can be 0. Okay, now if we check if they're all the same, is it enough to then check if one of them is not 0? Yes. Okay, because if they're all the same and the first one is not equal to 0, then you know from those two facts that the second and the third aren't also equal to 0. So we only actually have to check whether or not one of them is equal to 0. Okay, okay, so let's do the equals part. I'm going to need several of these. Okay, so I need to check, is it the case that tile 1's value is equal to tile 2's value? And is it the case that tile 2's value equals tile 3's value? Okay, and then I will also need to say, I'll just pick tile 1 to compare to 0, and I'll say not equal to 0. Okay. Okay, so I've got these 3 pieces. Do we buy that I need those 3 pieces? And the question now is, how do I combine them? Oui ou non? So do we buy the 3 pieces? I haven't put them together yet, but do we buy that these are the 3 pieces we need? Okay. How do I need to combine them? What do I need to be true about all 3 of those statements? Well, I need all 3 of them to be true simultaneously, right? So that's code for which word, which Boolean operator. And, okay? So I need to do a Boolean operation, and I'm going to need 2 copies of this. Okay, so I need all 3 of these things to be true, and so I'm just going to plop one of them into each of the sockets, and as you can see, this starts to get a little messy because it doesn't really fit on the screen. Okay, I need all 3 of those things to be true simultaneously. Okay, and that's an and condition, right? So I've had to use 2 of them to build it, because essentially I've done thing 1 and thing 2 in parentheses, and then anded that with thing 3. Okay, but the and operation is what we call associative, meaning does it matter what order that I do the anding in if it's all 3 of them, or if I do 2 ands? So is there a difference between, I'll write it over here on the sideboard. So I have 3 big messy statements. Let me call them P, Q, and R for short. Is this any different from this? Are those the same thing logically? You do get the same result in this case. Now, if I start switching the word and there to or in some cases and in others, then no, it's most certainly not always true, right? So you have to be careful about when you mix Boolean operations. But if it's the same Boolean operator and also and, then you can do this, okay? And so I don't have to really worry about my parentheses per se. And in this case, there's no parentheses here. The parentheses are sort of represented visually by how I sort of stacked up the sockets. Does that make sense? Like in a real language, like if I flop this over into Python mode, then I would actually put parentheses there to group things together. So I could do, well, either of these ones. It wouldn't actually matter, but I would explicitly put in these parentheses there. Okay. Okay. Does that make sense? So I've made a Boolean object, and I know it's a Boolean object because what is it symbolically? It's got the little pointies shape. So that means it can only ever be a true false thing, and that means I can use it with, where did I put my coffee? Does anybody see my, oh, there it is. Sorry, can't teach without this liquid courage. That means I can use it with an if or an if then else statement. Okay. And so here I want to use I'll just use the if. And I'm going to plop that into the socket. Okay. And then it turns the color. Okay. So what this little if condition is going to check is what? Just the top row. Okay. So what am I going to have to do once I finish creating this if statement? I'm going to need to make 7 more copies of it so that I have 8 things, and then I'll just have to change the numbers to check the second row, the third row, the columns, the diagonals, and so on. Okay, good? Sure. Tile 3, and that one of them is not 0. Right? Yeah. Okay. Now, does that make sense, right? So if tile 1 equals tile 2 and tile 2 equals tile 3, do I have to check whether or not tile 1 and 3 are the same? Like, I could check that, but do I need to? No, because math, right? Well, I know that that's going to be true, and so why bother checking it if I know it's guaranteed? Yeah? Okay, now then the non-zero part, and I know that's a not equal right there where my mouse cursor is. It's a little hard to see on the screen. Why is it enough for me to check that tile 1 is not equal to 0? Why do I not have to check tile 2 and 3 while I'm at it? I mean, I could check all 3 of them, but why don't I have to? I know that they're all the same, and so if one of them's non-zero, then all 3 of them are non-zero because they're all the same thing, right? So again, because math, yes, isn't it wonderful? Yeah. Okay. All right. So the body of this if condition will only execute if the top row of things are all the same state and none of them are the 0 state. Okay. So, well, who wins if this is true? If this statement evaluates to false, then nobody's won, and that's fine. That's the end of it. Okay. Um, but yeah. Okay. So who wins in the situation that the top row is all the same? Well, who could win? 1 or 2. Okay. So here's where I'm going to be smart. Okay. This value, tile state, if all 3 of them are the same and all 3 of them are the number 1, then that means player 1 has won, right? Otherwise, player 2 has won. And so I can use that number as its value tells me who just won. If it's a 1, that means player 1 won. Otherwise, it means player 2 won. Okay, does that make sense? So I don't have to make an if condition here. I can just say player such and such wins and replace. So whatever the numeric value of that thing is, that's the number of the player who won. Yeah. Okay. So, so this is being thinking with portals. Did you guys play Portal? Yeah. Yeah. Have you not played Portal, the video game? Oh. So, okay. Well, you ought to because A, it's always super ultra cheap on Steam because it's old by now. B, it's a really awesome game. And C, if Apple would ever make it so that you could buy custom voice packs for Siri, they could literally just print money, right? Because if I could have Gladys as my Siri voice, I would pay good money for that. I would pay more money than it's worth for that, right? That would also be good. It's Morgan Freeman as Siri. Um, so Tim Cook, if you're listening to my stream, because I know that, yeah, then you can do that. Okay. So what do we want to do to the game in the situation that somebody has won? Well, we should probably tell that they have won. Okay. So under the game menu, we had this game over thing, but we could also do I think it was under scene or maybe it was info. Um, there was a thing that said splash. No, where was it? You guys know what I'm talking about, right? Oh, here it is. Okay. We could splash text player. Okay. Player X wins. Okay. But what do I want to do with where it has the X? I just typed an X for right this moment, but yeah. Hmm. Whichever player won, because it'll either be the number one or two. Okay. In order to do that, I need to come down to text. Okay. And I need to do um, basically put three pieces of text together. Okay. And so what I'm going to do is I'm going to use this thing called join. Okay, and it's a little hard to actually. It's not so bad on the projector. On my computer screen, the yellow makes it a little hard to see the white text. Okay, so what this object will do, this join function, is it will take multiple pieces of textual data, okay, and combine them into one larger thing. Okay, so the default there is hello world, but what do I want to make this? I want to make it player something wins. Okay, good. All right, and then what am I going to put here in the middle, dude? Yeah, this variable. Okay, now here's where I have to be a little bit careful because what kind of objects does the join thing operate on? Text. But what is tile state? It's a data, but what type of data is it? Like here, we've been using it as a number. What do we want to use it as here? As text. It's the same data, but we're changing the data type. Okay. So let's just, for sake of demonstration, say that I put this right there. Okay. And let's see if MakeCode is happy with that. Okay. Now, it might be because it might do automatic data conversion, right? A number and a piece of text are not the same kind of data. Okay, so in order to test this, I need to create a win along the top row. Okay, without anything else. So let me do X, O, X, O, X. Oh, why didn't anything happen? I never called the function. So I created it, but I never called it. Okay, so where should we call the function? How about right here, right? We'll check whether or not somebody has won only immediately after a tile gets played. Doesn't make sense to check any other time. Okay, all right, so let's try that again. All right, so X, O, X, O, X. Player one wins. Okay, it's a little hard to see there, but what do you notice there? So it did do the data conversion for us, so we didn't have to worry about that. Is there anything else we should fix up? Yeah, there's no spacing. So let's throw in some spacing. Okay, but it looks like that works. Okay, and what happens if I hit the A button? We're back to the game. What should we do? Change the game state or just reset the whole thing back to um, the beginning. Okay, and there fortunately actually is a function for that. Okay, and let's put that in here in the this guy. Okay, and then also I'm going to add a space after player and before oops wins so that there's a space in between the number and the text. Okay, so let's test this. Okay, so I want XO XO X, player one wins. Okay, and now let me get it so that player two wins. Okay, and the game resets every time. Okay, so that looks pretty good. Yeah. Okay, so what do we need to do here then um, for all the other situations? Can I basically just copy and paste this if block 7 times at this point? Yeah, but I need to make a few changes to each one. Okay, namely, so like, let me go ahead and do the next one. Okay, what do I need to change about this second copy? Yeah, key. Huh? Yeah, which tiles I'm looking at, right? So the first block, I was checking tiles 1, 2, and 3. What do I want to do for the second one? So for this block here, if I've already checked 1, 2, and 3, then do 4, 5, 6. Okay. So we'll check all the rows first. So 4, 5, 5, 6. And this one can be 4. And then this one can be 4. Okay. So that will check the second row. Yes? Okay. So we've got the first and the second row. Now what? Yeah, we'll need to do the third row, the 3 columns, and the 2 diagonals. Okay. Now, for sake of time, you guys can do that on your own. That's basically just copying and pasting. It's the same thing. Okay. What's the one other situation that we have to deal with other than the other rows and columns and diagonals? Right. So the rows, columns, and diagonals, that's basically a solved problem. Yes. Huh? Yes, the tie situation, the stalemate situation. Okay, when does a stalemate occur? All 9 tiles have been picked and there's not a winner. Okay, so how do I know that there's not a winner? Okay, well, if I run through all of this stuff, so I'm going to put the stalemate checker at the very bottom of it, okay? Because I will only get there in this function if all of the checks for whether or not there was a winner have failed, okay? And what other condition do I need to check? That the number of tiles that have been picked is equal to 9, okay? So I'll check whether or not the number of tiles is equal to, or picked tiles is equal to 9, but by putting it after all of the other winning code, it will only get executed if all of those winning pieces of code fail. Does that make sense? So that means there was no winner, and I'm checking the stalemate condition. Okay, you guys see the logic here? Okay, so let's put that in. Okay, and so what do I need to check? I just need to check if the number of picked tiles, which was, what did we call that? Tiles picked is equal to what? 9. And then I will do a splash. I'll get rid of the join, and I'll also do a reset. And so I'll just say, there's a tie, nobody wins. Okay, so good. All right, so let's test this out, and this is actually a little harder than it should be, to generate a situation where we have a tie. Okay, so let's do X, O, X, O, X, O, X, O, X. Okay, it worked. Okay, and then reset. Make sense? Okay, so what's the only thing we need to do to finish this? Bueller. Bueller. Is he not here today? Have you guys all seen that movie? Yeah. Yeah. So the only thing that we need to do is to make more copies of this to check the other rows and columns and diagonals, right? So we've got row 1 and 2 checked, but we need to check the third row, the 3 columns, and the 2 diagonals. But it's essentially just copying and pasting this one of these if blocks and then changing the numbers to be the correct ones for that row, column, or diagonal. But other than that, we're done. Yes. Uh, you would probably need, I think, at minimum 4. Okay, because you could do because rows are different than columns are different than 2 diagonals, right? You could look at the rows as being somewhat similar because 1, 2, 3, 4, 5, 6, 7, 8, 9 are kind of structurally similar. Okay. And then for the columns 1, 4, 7, those are all 1 mod 3, 2, 4, and right. So you could check the remainder, the modulus, right? Do you guys know what a modulus is? So I know he does. Um, so if I divide a number by 3, like go back to elementary school. When you guys first learned division, how did you learn? So if I asked you what's 7 divided by 3, what would elementary school you say?
7/3.
2 remainder 1, right, would be the very first thing you learned. And then you later learned to say, oh, well, it's just 7/3 or a mixed fraction or whatever. And then you got into high school. So, like in elementary school, we said, no, 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 just do the remainder thing, right? And then you got into like middle and high school, and we said, no, 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 don't do the remainder thing. And then you get into college, and guess what we tell you?
No, not do the
Do the
remainder.
remainder thing, because the remainder is actually what matter. Well, sort of. Okay, so a modulus is operator is when you look at that remainder. Okay, and it turns out that this is really useful in a bunch of mathematics, right? Um, so, for example, the columns, the tiles for the first column are 1, 4, and 7. Well, all of those have remainder 1 if you divide by 3, right? 2, 5, and 8 all have remainder 2 when you divide by 3. And 3, 6, and 9 all have remainder 0 when you divide by 3. So what possible remainders can you get upon division by 3? 0, 1, or 2. That's it, right? And modular arithmetic is the what we call looking at those things. So you can. So Key's question was: is it possible to basically make it so I don't have to have 8 copies of this thing? And sort of, but you're going to have to probably have at least 4 because rows look different than columns. A, um, and then the 2 diagonals are kind of weird. Okay, so yes, is it possible? But this is one of those situations where how long would it take you to figure out a good way to write it? Is it faster to just do 8 of those, right? And for something simple like this, I just do 8 of these, right? Because we can always, and this is the whole reason we want to use a function, right? We can just bury it in this function. We only have to write it once, and then we can kind of put it away and never have to think about it again, okay? Um, Okay, so good question. Now that modulus thing can be really useful for stuff, and most programming languages have some sort of way to compute it. So if I go in here to the math tab, for example, you see how it has this guy here, remainder of something divided by something. That's why it's here because we use this quite a bit um, in um, in programming. Okay, so the remainder, right? If I divide it by 3, what did we say the possible remainders are? 0, 1, and 2. Okay, and obviously, yeah. So the way modular arithmetic works is it's actually kind of like clock arithmetic. You can think of the clock as being mod 12, right? Because, well, so let me think of 12 as really being 0 just for the sake of discussion. But what happens? It goes 0 through 11, and then what happens when you hit 12? It just starts all over again, right? So it's sort of cyclical rather than being infinite. Okay. Um, yeah. Anyway. Okay. So I think that's good. We basically have tic-tac-toe done, with the exception of a little bit of copy paste, but otherwise it works. Okay. And so what I want you guys to kind of think about then is sort of the procedure. Um, or how did we go through this process of designing tic-tac-toe, right? Now, I happen to have programmed tic-tac-toe before, right? So some of these things about decisions are things that I know that I've done the last time I programmed it, okay? But the thought process and sort of the strategy of carving up the like, if I just said to you, go program tic-tac-toe, what would happen?
Look at the screen like it would be like,
Yeah, exactly. You'd sit there and you'd be like, I don't know, right? Because it's too big of a question, right? It needs to be broken up into smaller pieces. And the first thing that we needed to do was to kind of consider, well, what are the big pieces that we need to work on? And let's tackle one of them at a time. Okay. So when you guys are thinking about, and we'll talk about this more, I guess, on Thursday, right? That it's kind of, we're basically at the point where it's time to pull the training wheels off, okay, and have you guys develop your own thing from scratch. We've done some examples, we've coded our own game from scratch, but now it's y'all's turn, okay. um, we need to think about, okay, if you wanted to program Mario, well, what problems are you going to need to solve? We already know how to make tile maps, okay? But what other things do we need to solve? What else is there? Like, say in the case of Mario, maybe there's like a big versus small Mario thing that we'll need to figure out how to do. And right, so you want to take your problem and carve it up into little pieces that by themselves are not too bad, and then it won't be so overwhelming. Okay. The other thing is you can't do everything at once, right? And the space shooter and the monkey game are sort of meant to be demonstrations of that, right? So when you first made the space shooter, it was pretty janky, right? It only had the spaceship in, and then the spaceship could move, but that was it. And then you added shooting, and then you added enemies, and then you added health, and you added points, and right. So you start with something, and you go through, and you continually are refining it and editing it as you go. Okay, but you have to start with something. Okay, now let me make sort of an analogy here that maybe I've made before, maybe I haven't. This is a lot like good writing, actually. Okay, so you're all in classes presumably this semester, where you've had to write a paper. Okay, give me an example of a paper we've had to write this semester. I know the freshmen are in EQ, but you had to write a paper about Gilgamesh. Okay, when was said paper assigned? Yeah, okay, fine. Beginning of the semester. When was said paper due relative to when it was assigned? Okay. And were there any due dates between the assignment and the due date? And what were those assignments that were or the due dates between the ultimate due date and the assignment date? Okay. Why was there a rough draft assignment? Because what happens if we just say there's a paper due and it's due Friday next week? You're going to do it Thursday or Friday next week. Okay. Whereas if I say, okay, I'm giving you a paper and it's due Friday next week, and what's due Friday this week? Okay, a rough draft. What happens then? When are you writing the rough draft? Thursday this week. Okay, but at least a week is going to elapse between the writing of the draft and when the final thing is going to go in, right? Well, what happens then once you have a first draft? Presumably you revise it. Now, how does revision work? Because it's not just putting it through spell check, that's not revising. Like you actually do substantive revision. Yeah. Game design is a lot like that, okay? In the sense that it's iterative. You have to get something down and then refine it over and over again. And part of that refinement process is playtesting. And part of it is having other people playtest your stuff. Same thing with paper editing, okay? Now, have any of you guys read, and I forget the name of the author of this little article called Shitty First Drafts? Okay, but you've heard about it? Okay. So, do you remember Lamont, I think it is, the author, Anne Lamont, something like that. Okay, so what's the premise? What's the point of shitty first drafts? Huh? Well, it can always be better, right? But you have to get something on paper to then have something to edit, right? So just get something on the freaking page because then you have something to work with, right? To improve, to rewrite, to recraft, to polish, to do whatever, right? Game design's the same thing. Get something in. It may be janky, it may be broken, it may be completely busted, but there's at least something there to work with. Okay. Um, yeah. So so I guess the point of the speech is, right, good game design is exactly the same process as good writing. It has to be iterative. Okay. So since we're getting towards the sort of second half of the half credit, right? We've only got what, 3.5 weeks of school left plus finals. Woohoo! Um, so what are we basically going to sort of transition to? Well, we're going to transition to you guys doing a bigger extended project, okay? And what comes with that is the shitty first draft, and then the revision and the adding stuff and so on, and also the play testing. And because you guys are all your worst critics, how do you play test stuff? Well, you need to test it, but somebody else needs to lay eyes on it because somebody else is not going to find the stuff that you are. Okay. Or somebody else is not going to know, like, if you play the game, you know where the door is to win or the treasure chest is because you were the one to program the dang thing, right? You're not a sort of player that's never played it before, a fresh player. You need that fresh set of eyes, and that's where all of you guys come in because you guys will do peer reviews basically to play each other's stuff, and we'll do sort of a couple increments of this sort of drafting process uh, to kind of get to the final thing. Okay, does that make sense? Okay. Now, the last thing I want to mention on that subject is um, I need to double check on the date. Let me pull open the calendar. Um, so on, I think it's the 23rd. Yes, the 23rd of April, which is in what, 2.5 weeks? It's a Saturday. Um, this is something that I was able to do a lot with classes pre-pandemic, and then the pandemic happened, and we couldn't do this. But I haven't mentioned the Carnegie Museum in town, the sort of kids museum, right? The Saturday afternoon game jam, right? Now, at that point of the class, y'all's stuff won't be finished yet, and that's okay, right? It's going to be pretty dang close to being finished, right? Because you'll only have like a week and a half left of the semester at that point. Um, but we'll be able to do that, and then of course, some number of the guys from the previous half credit will join us. Okay, so I'll get you guys details about that, but roughly speaking, that along with um, the um, the sort of doing the peer review stuff is going to be how you polish a game into something really good.
What time with the Carnegie?
Like 1 to 3 in the afternoon, roughly. Um, I need to confirm with them, but I think that's what we were planning for. So I would need you guys there about noon to help get some stuff set up. We'll just steal a bunch of, well, you guys all have your own laptops. I'll steal a couple extras from physics. And then I'll get like a pile of Jimmy John's or something because uh, Wabash always eats, right? So anyway. Okay, so sound good? All right. Well, I will see you guys on Thursday.